things. So you may not have had quite enough time to finish solving out the entire problem, and that's okay. What I'd like to know is, does anybody have what they think is a good choice for X, or good choice for U? Ben?
I used cosine.
Okay, so Ben, you use cosine X. Okay. Anybody choose anything different?
Sine X?
Sine X. Okay, so. Okay, other options. So everybody either chose U equals cosine X or U equals sine X.
Would you just leave it as sine X, so it wouldn't be sine of X cubed?
Okay, so possibly another option might be to let U be equal to sine of X, the whole thing cubed like that, or sine cubed X equivalently. That's another option.
When I was doing some of the problems, I'm not sure if I've seen it right, but what I kind of noticed is when you choose your U becomes, when you differentiate it, it's supposed to become with the other, kind of like the other half of the problem.
Okay.
Something like that, is that right?
So that seems totally reasonable. Okay. So thinking about this problem, one thing that I might do right away with this problem is to rewrite sine cubed X as sine of X to the third times cosine X dx.
Could you still break it up even more, right? It's sine squared X times sine X times cosine X?
Absolutely. You could also do that as well. Yep. So the reason that I'm writing it like this is one thing that I like to see about, one thing I see here is that when I'm writing like this, I see an inside function. And remember, U substitution is somehow undoing the chain rule. And the chain rule has to do with an inside function and an outside function. And so if I see an inside function sort of forming here, then that might be a good choice for me. So the first U that I'd like to explore is the option of let's let U be equal to sine X, because that gives me the thing inside the parentheses as my U. So let's look at that one. We'll come back to let U be cosine X in a minute. But in our first round here, we're going to let U be equal to sine X. And so this thought process, Mark, is that right? Mike, sorry. I will get it right after about 8 more tries. Thanks, Mike. Okay, so one nice thing about this is right away, if I say, okay, sine X, in my head, bam, the derivative is cosine X. And over here, what I see that's left over is a cosine X. So I'm pretty happy about that. Things are probably going to cancel for me. So let's go ahead and work through that. When we do that, we have du over dx is equal to cosine X. And that tells me that dx is du over cosine X. So when I go back to work through the substitution, I have the integral of u cubed times cosine X times du over cosine X. And this is a very good choice because our cosines cancel. Our derivative of our u choice canceled the remaining portion of the integrand. And so now at this point, we now have the integral of u cubed times du. Everything is in terms of u's. And I know what the antiderivative of u cubed is. I just need to use the power rule. I add 1 to the power and divide by that new power. And I have a plus c on the end. Now I'm not quite done. I still need to turn back into x's. And so since my u choice was u is equal to sine x, then when I replace my u, I have sine to the 4th of x, or sine of x all raised to the 4th, divided by 4, plus c. All right. Now this worked out pretty straightforward for us with this choice of u, with the choice of u equals sine x. And it was really nice because there was one cosine, and I know in my head the derivative of sine is cosine, and so that one cosine is going to get knocked out. It's going to get canceled by our derivative. All right, now, Ben, you suggested let's let u be equal to cosine. Let's see what happens with that. So, option 2. Option 2, we, again, are starting out with sine of x cubed times cosine x dx. And we're making the choice to let u be equal to cosine x. Okay, so I make this choice, I do my derivative. equal to negative sine x. Okay, I'm feeling somewhat positive about this because I see a sine x over here, I see a sine x over there. The negative we can just carry along, that's no big deal. So I keep going and I solve for dx. dx is equal to du over negative sine x. Alright, so back over to our original. We have the integral of sine of x cubed times u, that's our choice for u, and dx is du over negative sine x. So things that cancel, the negative sign, we can pull that into the front, and it doesn't matter whether it's in the numerator or the denominator, so I'm just going to write that as a negative sign in the front. The signs, well, one of those cancels. And so we're left with sine squared x times u du. All right, so at this point I'm mildly sad because I have x's and u's combined together. Right? Now, Ben, did you have some success with this?
Yeah.
Okay, talk about your success.
Sine squared x is equal to cosine x minus 1.
Okay, so there's that trig identity that says sine squared x plus cosine squared x is equal to 1. That is the most important trig identity you will ever need to know. If you don't already have it as a tattoo, you should consider getting that as a tattoo on your arm or your leg. It is not cheating if it's tattooed on your arm in a permanent fashion on an exam. So as long as it is
Just
permanent,
on your arm?
Anywhere you want,
Oh.
as long as it is permanent. If it's a temporary tattoo, that's cheating.
Does that go for any mathematical formula tattoos?
In my class, yes. If it is a permanent ink and needle tattoo, it is not cheating. Okay, so here's our Pythagorean identity, the uber important trig identity. And so this is quite fun because we can solve that for sine squared x. So sine squared x is equal to 1 minus cosine squared x. Okay, so that's a great observation. And the reason that's a great observation is that we can replace sine squared x with 1 minus cosine squared x times u du.
Cosine squared x just become u squared.
Yeah, so now what I see up here is pieces that look just like our u. And so cosine squared x is the same as u squared. So we have negative the integral of 1 minus u squared times u du. So we're happy. We've used a trig identity in order to change our integrand entirely in terms of u's. Now we're not quite ready to take the antiderivative yet because we've got some multiplication we need to distribute through the parentheses. And so we have negative the integral of u minus u to the third du. And now we're ready to take an antiderivative. So our antiderivative looks like negative the quantity u squared over 2 minus u to the fourth over 4, and the whole thing we add on a plus c. All right, now, again, technically we're not quite done. We still have our antiderivative in terms of u, and on this example, our u choice was cosine x. And so our final answer will be negative the quantity cosine squared x over 2 minus cosine to the fourth of x over 4, and then a plus c on the end. And so we've come up with what look like two entirely different final answers. And if you take the derivative of each of these, you should come up with sine cubed x times cosine x. Although it might look a little funny on this one over here. So how do you know if these two are equivalent?
Should you just plug something in?
Well, do they have to be exactly equal to each other?
No,
No.
because the C is unknown.
Yeah, the C is unknown. Technically, these are two different C's, and so I might call this maybe C1 and C2 if I want to compare them. So how do I know if these two are the same? Well, one thing I can do is I can graph both of these expressions on my calculator, and their shapes should be exactly the same. And then one may be shifted from the other, but their shapes should be exactly the same. Another way I can check to see if these two are the same is that I can take one of them and use some trig cleverness, use some trig identities to eventually come up with the first one, plus or minus some sort of a constant. And so I would encourage you to see if you can figure out how to get from one of these expressions to the other one via some trig identities. We won't do that in here, but I would encourage you to try that on your own. Okay, any questions about that? Okay, so these were two possible u values. Now, a third possible u value was u equals sine cubed x. And I will encourage you to try that one out and see if that works for you, see if you can make that u substitution work. We're not going to do it right now because I want to take a 10-minute break at this point, but see if you can make that one work, or see if you can find another u that would also work. Okay, please take a 10-minute break, and I'll see you soon.